Hey guys, welcome to Aloha Finances. This website is going to focus on portfolio theory and be based in the programming language R. R was difficult for me to pick up, so I'm hoping this video or set of videos can help some people learn the language a bit faster. The first video is going to focus on importing data from the Fama French website, and then once we've imported the industry data, we'll begin to learn how to manipulate the data set. And finally, we'll calculate some basic summary statistics for the 47 industries, an equally weighted portfolio, and the market portfolio. Hope to see you there. Okay, let's get started. The first thing we need to do is go to my website at alohafinances.com and download the industry data. You can find it under the download section under 47 Indus-Day. You can also go through the Fama French industry website, but you'll have to upload the risk-free rate and the total excess market return. So I've done a bit of a shortcut for you here. Also, just make sure to save this file as a CSV, as it makes it a bit easier to import into R from Excel. And then once you have the data saved down, we can get started in R. Okay, we made it to R and we're ready to import the data set. The first thing we need to do is set the current working directory to where the file was saved. So we do that using setwd, parentheses, quotations, go to the folder where you saved it, go ahead and copy that in there, and then just remember to add an additional backslash so that the working directory is set correctly. And then once we've done that, the next job is to actually import the data set using the read.csv function and assign a variable to it. So the way you assign a variable is just with this back arrow, and then we need to use the read.csv function, quotations, and I know my file is called 47 Indus-Day, and then just remember to add the .csv after to upload the file. So we run that code and we see that there's been 12,000 variables or 12,000 observations and 50 variables. So it looks like we've correctly imported the data set. And with the data set this big, sometimes it's useful to use the head function and then just type in data to see the top of the data set. And you can see that we have the risk-free rate, the excess return on the market, our 47 industries, and a date. Now that we've imported this huge data set, we want to define the sample size we're going to be using for our analysis. The first step in this is to define the width of the matrix using the length function, but we also want to assign a variable to this, and we're going to call it NIND for a number of industries, and then length. So the length function will determine the length of a vector or a matrix that you put into the function. So we're going to put in this big data set matrices, and then we're going to subset with these brackets and use 1 comma, meaning we only want to use the first row in all columns. And then we're going to subtract 3 to exclude the date column, the excess return on the market column, and the risk-free rate column. And then we'll check to see that returns the correct number of industries, and you can see down here that it's 47. Next, we want to combine the vectors of our dates, industry returns, and total market returns into one matrix. We're also going to assign a variable to this and call it RATS for returns. And we're going to use the cbind function to combine the vectors into one matrix. So cbind data, and then subsetting again, meaning in this data set that we've imported, we're only going to use the first column, which is the dates. And we're going to combine that with data, subsetting again from column 2 to the number of industries plus 1 to account for the date in the first column. And then from there, we're going to subtract the risk-free rate, which within the data set is the 50th column, or it can be denoted as number of industries plus 3 because we have 47. And then we're also going to combine that with our total excess market return, which again, subsetting is in the 49th column. So it's the number of industries plus 2. And then we'll check that we've returned the correct values with the head function, and then returns. And you can see we have the excess market return, the 47 industries, as well as the date column. Now that we've created a matrix with daily excess return data for the 47 industries, the total market return, and corresponding dates, we want to define the sample period. So we'll do that by assigning variables for the beginning and the end of the sample period. Y begin, let's say 2009, and Y end, let's say 2013. Next, if you look at the dates through the data function, now that we've created a matrix with daily excess return data for the 47 industries, the total market return, and corresponding dates, we want to define the sample period. So we'll start by assigning two variables by beginning for the beginning of the sample period, let's say 2009, and the end of the sample period, let's say 2013. And if you also look at the dates column within the actual data set, you can see that all the dates are multiples of 10,000. So knowing this, we can use that to use an AND function to define the returns between the sample periods. So we'll start with returns subsetting an immediate comma because we only want to be dealing with the rows. And again, returns subsetting again with the first column, which is the date column, is greater than y beginning times 10,000. And returns again, subsetting, once again, only the first column is less than the end of the sample period plus 1 to include times 2013 times 10,000. And let's just make sure that returns the correct value. And you can see within the global environment that our return matrix has significantly less observations than our data, which probably means this is correct. The last step in this video is to calculate annualized summary statistics for the 47 industries, the market portfolio, and an equally weighted portfolio. So I'm going to start by assigning a variable DPY to 252 just to denote the number of trading days per year. And we'll start with the 47 industries in terms of calculating their mean and standard deviation. So we'll begin with assigning a variable mu_m, and we're going to be using the apply function, and there's three terms to the apply function that matter right now. The first term is the vector matrix being manipulated by the function. So we're going to use our returns matrix, and we're going to be subsetting that from column 2 to the number of industries plus 1. And then the second term in the apply function can either be a 1 or a 2, meaning the function applies it to the rows of the matrix or the column of the matrix. And in this instance, we want the column, and we want to be calculating the mean. And then we want to multiply that the number of trading days per year. And let's just make sure we have a correct answer. And you can see that the annualized return data for the 47 industries has been populated into the console. Great. To calculate the standard deviation, we are again using the apply function with two small differences. So we can go ahead and assign a variable, copy the apply function from the top, and instead of the mean being applied to the matrix, we're now going to apply the standard deviation, and instead of multiplying it by n, we're going to multiply it by the square root of n. And let's make sure this populates. And now you can see the annualized standard deviation populated. For simplicity purposes, I've gone on and coded the annualized mean and standard deviation of the market portfolio as well as the equally weighted portfolio. If you want to go ahead and try and code that, it's probably a good exercise, but I've gone and provided the answers down in the console if you want to double check. This concludes the first video of getting started in R, and I hope you were able to take something away from it. The next video is where the real fun starts and we begin forming the efficient frontier. I hope to see you there.